So what we are going to do in this core machine learning course, so is something different, right? So what is the thing different is, so far for taking a database, what you will be doing, you will be going to Kaggle or you will be going to some other websites, downloading it, and then you will be using it, right? Whether it is a usual practice, no. Whenever you go into a company, there will be not any database available for you to do any projects. Say, for example, if you're going for an hackathon project or a proof of concept (POC) project, right? Those hackathon students will be hearing this particular word again and again: POC, POC. What is POC? POC is nothing but proof of concept. What is proof of concept? Is nothing but I'm actually discovering a new thing, not inventing. I'm actually discovering something, whether it is correct or not. That should be proved. So if I'm doing something which is not at all known to anyone, then the database or the raw material what I use for that particular algorithm also should be new. It should not be already available. Then what we have to do, whether we have to type the database, no. There should be something called as information retrieval. I need to do something called as information retrieval. I need to retrieve information and I have to use that information into my database. So how to do this information retrieval is actually another task. So this information retrieval can be done in several ways, and we have Python packages to do. We have scrapping packages, soup packages, and so on. Everything we are going to learn to develop our own databases. That's what we are going to do. Example. Now I'm having here the Flipkart page. Yes. Now I'm giving you a task, right? Just to say me, I have seen Flipkart page several times. Just to say me, how many entities are there here? If I want to write a CSV file for the Flipkart page, how many entities can I have? Quickly, everyone. I want everyone to answer quickly. Whatever is before you, is you can say. First, I will start. I will start product name. I have said product name. And any other thing?
Brand, price, configuration.
Brand price. See, one by one. Any one student, one or two is enough. So you again said three. Next, most
Color.
important what you can said is price. Color. Somebody said color. Very good. Next, see, I have typed here Redmi. So only phone items are there. Phone and electronic items are there. Next,
Customer rating.
Sir,
ratings.
pixel
Very good.
clarity, sir.
Very good. The most important thing is ratings. Very good. Next, picture clarity. Where it is?
Processor.
No, sir, camera pixel.
Yes, this
Camera
13.
pixel.
Okay, 13 MP, 5 MP. Okay, next.
Review.
Storage.
Okay, storage. I'm saying very good. You have you understood? See, I have said very good for some other items where you are saying some numerical data items. As you all know, machine learning algorithms will act very nicely on numerical data items. If it is a non-numeric item, I need to convert it into numeric and then I have to work. So you can understand, right? So those numeric items I was very fascinated on, right? Next, any other items?
Flipkart assured sir.
Snapdragon.
Flipkart assured, how can it is coming for yes or no? Flipkart assured yes or no?
Yes, sir.
Boolean like. Okay, okay, okay. Next,
Processor, sir.
Snapdragon, sir.
huh?
Snapdragon.
Snapdragon in the sense.
Processor. Playback time, sir.
Processor,
Oh,
sir.
okay, okay. Processor, yes. So I can have product name. The most important things I'm saying: product name, ratings, reviews, price, RAM, display. What do you say here? Camera, battery power, warranty, some numerical items. Now, a task is given to you. Here in Flipkart, how many Redmi items can be there? Can you say randomly how many items Flipkart can have in Redmi? Different items. Can you fix it? See here, 1 to 40 of 1000, sorry, 1,73,597 for Redmi. Can I extract this into a CSV file? Is it possible or not possible?
No, sir, not possible right now.
Yes, right now not possible. But I have something called as Python. To have some several packages, and I can use those packages and extract the entire Flipkart page into a CSV file. I can do that. CSV or Excel or any other file format I want, I can do. That thing is called as information retrieval. So this is the first task what we are going to do. Next, I'll go to another website. Hope this website it's actually known to everyone. ESPN Quick Info. Whether everyone know this? Whether everyone know this website?
Yes, sir.
No, sir. Don't know, sir.
Okay, ESPN Quick Info website is actually a website for all cricketing things. So starting from the cricket start to the present, everything is available in this Quick Info, right? So you can see that score everything. But what we are going to do is something different. So I came to ESPN Quick Info and Stats Guru. I have something called the Stats Guru in ESPN Quick Info, and here I have a search engine. Right? Why I took this is one of the most famous data warehouse. I'm not saying database. Why? Because I'm saying it is a data warehouse because it is a very large database, starting from the earliest first ball of the cricket to the current ball of the cricket, ball by ball. Every information is stored in this particular database. You can think it is a very small page, but it is a very big varying page. You can analyze several things over here. Just I click ODIs here, I click batting here, and I get this many number of query items. I can give the query items, and I can click submit query, and I can get all the databases I want. Right? I can get the required database, and I can extract it. This is the thing. But the problem with this is if I have a large amount of database like this, I need to copy this, I need to paste in a CSV file and then go with it. But rather, I can use the Python information retrieval packages to extract items from these pages and paste it in a CSV file and use it as a raw material for my machine learning algorithms. I can use machine learning algorithm to solve that. So these two things we are going to do, right? These two databases, assume I'm going to expand Scrap, Flipkart, the ESPN Quick Info, and so on, right? So being the course coordinator, I have designed my lab manual, and I'm a cricket lover, so I designed my entire lab manual in cricket. So cricket, if you have seen, hope I have uploaded the course plan in the syslogin also. So if you have seen it, you have seen the lab session also. See here, first is going to be data scrapping. Next is going to be multiple linear regression. I hope that many students have done already the linear regression. So I went directly to multiple linear regression. A test on linear regression will also be given. Okay. So a multiple linear regression, what is the scenario is model the strike rate of a batsman in ODI, right? So everything, if you see, will be something related to a particular database, so that at the end you will be having a particular database analyzed using several machine learning algorithms. So it itself, this laminar by the end, if you have, will have a very good analysis on a particular database. The same thing if you apply in some other database, then that database you are actually researching and you are actually producing an output. So like that I have designed my lab manual. So first is going to be a multiple linear regression. Next, k nearest neighbor, Bayesian tree learning, clustering. Three ways we are going to do the clustering. One is k means, another is k medioid, another is db scan. In addition to this, we are going to do another clustering called as Clarence clustering also we are going to do. Next is support vector machines. So these 9 are actually fully based on a particular scenario, and the final one is going to be on handwritten character recognition, my favorite thing, that is handwritten character recognition. So these things we are actually going to do, but not in the usual fashion in what we have done in introduction to AML or predictive analytics. But we are going to do it in a something different fashion. So what we are going to do is we are going to retrieve our own information and use that information to model our own data algorithms. Model the algorithms for own databases. So this is what the industry people actually prefer. I take some database, I apply an algorithm and it get the result. This is usually available even in several GitHub pages. If I do the same thing over here, then there'll be no use, right? So what I do is I model the algorithm for own databases. Own database, how I can get using some information retrieval systems. Through that, I will extract my own databases. I will apply my algorithms over it, and I will be doing that. Because this is the only thing we are going to do. Why? Because we have already done this not for one database, but our already existing database. But we are going to do another major thing called as, or I can say not overfitting, I'll say model evaluation. So in the entire machine learning syllabus, what my concentration will be is the model evaluation. Because we know algorithms. When I say, show you the lab manual, many algorithms, if you see, everything are more clearer, and you are having some gist or even some expertise on each and every algorithm, except some few. So what I'm going to do is I'm going to go as deep as possible to do a model evaluation metric. In earlier days, I think during the second semester, right, Shirdi asked me one question. So something around the overfitting. I don't remember the exact question, but at least around model evaluation. I had like improvising the model and so on, right? So that's what we are going to do in this particular semester. If I apply a linear regression algorithm on a particular database and I get the result, then what I will do, I will use the model evaluation metrics. I'll say what is accuracy, what is the confusion matrix, everything I'll be getting. I'll projecting it and I show the visualization and see this much percentage is achieved. Then what I have to do to improvise this percentage, we have to see. If it is a deep learning kind of, then I can reiterate, I can go for as many number of epochs and I can achieve it. Here in machine learning, we need to do some model evaluation things. We can increase the learning rate or model the gradient descent, anything I can do, and I can make the percentage go higher. I mean the accuracy percentage to go higher or the error percentage to come as low as possible. So those model evaluation is going to be the key for all these things. So what are the model evaluations we are going to concentrate is, first is we are going to concentrate on overfitting. We are going to practically see how the overfitting is going to happen. Then we are going to concentrate on how to overcome this overfitting by using, we know that overfitting can be overcome using validation techniques, not only single validation, we have many validation techniques, everything we are going to use. Then how to remove the missing values, then how to remove outliers. That outlier detection alone has several algorithms to see how to remove the outliers. Then how to overcome some erroneous values. So there are two things. One is outliers, those kind of data which do not have any relation with the other data present in the particular database. We say it an outlier data. Some data which are missing, I'll say it as missing data. Some other things, missing values cannot be categorized as NA values. I say it is NAs. Right? In database schemes, we say it as NA values. So these things and all we are going to do. In addition to outliers, missing values and overfitting things, we can also concentrate on erroneous values. Sometimes some values may be erroneous. Where it will be coming is, it will be coming through calculative fields. Right? In Tableau, hope in Tableau you have seen, we have something called as calculative field. What this field is, the value in the field will be calculated from the other fields in the database, some dependent value. That value they will be changing by intentionally will be changing to model something, right? If any error is present in those calculative fields also, we need to understand and we need to model the same. So those things we are actually doing the model evaluation things. So for every algorithm, we are going to use this and we are going to demonstrate this, right? So this is the thing we are going to do. And what are the algorithms we are going to concentrate on is, first is going to be multiple linear regression. And if I say multiple linear regression, I will include a linear regression and logistic regression also inside. Then only I'll be going into multiple linear regression. Nothing more. What is the extra is, I'll be concentrating on a particular paradigm with respect to a single input and or multiple input. If I go for a multiple input, then I say multiple linear regression, right? So for example, the first thing is going to be, if you have seen a lab manual, I need to model a strike rate of a batsman. See, Sachin Tendulkar is having a strike rate as 86. Then another Ricky Ponting is having a strike rate of 80, right? So it is not that we need to need full cricket knowledge for modeling this. Just being a machine learning scientist, we are given a database and we are need to model it. I cannot directly read from it. Instead, what I'm going to do is I'm going to retrieve the entire information from this website and put it in a CSV file or an Excel file, and I am going to apply my machine learning algorithms to do the same. So that thing I'm going to evaluate. So I'm going to take the strike rates over here, and based on this, I'm going to model yes how the strike rate is going to depend on the for example average. Based on the average, strike rate is dependent, or based on the number of matches played, strike rate is dependent, and so on. If I take matches alone to determine the strike rate, then it goes for a linear regression. If it is for matches, runs, average, and so on, if I take more than one variable to model the strike rate, I go for a multilinear regression. So that's the thing that we are going to say, right? So those things we are going to do in multiple linear regression. Next, what we are going to do is we are going for the k nearest neighbors. Right? This is also an algorithm which we have seen earlier. But the thing to see here differently is we are not going to see with an earlier database, but we are going to do with an exact scenario, right? Like what will be coming in some hack challenges or industrial questions. We are going to have a question, and based on that, we are going to identify the nearest neighbor in real-time scenario. Similarly, we are going to concentrate on clustering algorithms. And what are the clustering algorithms we are going to, sorry, I'll be coming here. And what are the clustering algorithms you are going to concentrate is K means, K medioids, next PB scan. So these three algorithms we are going to see. And in addition to this, we can also see Clarence. So these many clustering algorithms we are going to see. Next comes the thing called as naive Bayes. Naive Bayes algorithm for classification. Finally comes SVM classification. So we will be having a comparison how the naive Bayes is classifying and how the SVM is doing the classification. Everything we can compare and see how much accuracy for the particular question naive Bayes is giving and SVM is giving. Both the thing I can understand, I can post them, right? Finally, apart from this, we have another thing called as handwritten character recognition, which is going to be done using PC, principal component analysis. And this alone is different. We are going to do it for an image data set, handwritten character recognition. So this is what we are, the entire machine learning we are going to do, right? Everything mostly will be dealt in practical, and for everything we are going to do it in a real-time data scenario, not taking or copying from any other Kaggle websites or GitHub websites. We are going to do it in own websites, right? Now what I'm going to do is I'm going to scrap. I mean the word scrap, SCRAP, scrap. I need to scrap the data from this website and put it in a CSV file or an Excel file in order to do that. So in order to, I will show the entire steps of how to do that. There is some initially it will be some extra thing to be done. That and all I'll explain later, not in the first class. See, this is my entire program what I've done, and I extracted everything. So this program, what it will do, you don't want to think that it is a very big program and all, right? The program, it is actually a snippet or a protocol kind of, where you can give the URL what you are going to scrap, and the package. What I'm using here is the Beautiful Soup package. Two packages are available to scrap. One is Beautiful Soup, another is Scrap Pipe, together called as Scrappy package. The two packages are available. You can use both. And I have used here Beautiful Soup package for scrapping the items from Flipkart. So what I'm going to scrap is I'm going to scrap name and price alone. And I'll explain how these things are done and what are these IDs, everything I'll explain one by one. Right? No issue, it should be known in the first class itself. Next class, this is what I'm going to do. How to scrap from Flipkart, how to scrap from Amazon, everything. And there is also, if you wonder, we have done a consultancy for a particular company. What I have done is, the company person asked me that I need to give them a website where they are going to do a local yeah, e-commerce site. In that e-commerce site, they are going to sell some products. So they are going to sell products only for the Tamil Nadu people. That's my small company. So what they want is they want their price to be displayed first. With their price, they want Amazon, Snapdeal, eBay price to be listed in the next site. So they should say each time their product is having a price, it should be compared with Amazon, Flipkart, and eBay or Snapdeal, those four kind of sites. And we need to compare the prices and say that compared to for this product, compared to these four sites, we are having the lowest price at least by 1 rupee. That's what they are given me a consultancy project. That is done. Everything done in this particular code only, not more than that. So that's why I brought that into our machine learning course. It will be very useful for you when you go into your higher semesters. So if you learn this, it will be very easy. It is not a very big task and all, except doing that website in PHP. Other things is in just Python only, right? Doing everything in the HTML. These and all nothing but the HTML IDs, class IDs, and so on, right? So that's what I did. So if you see the flip items here, we got all the databases to be present. And if you have seen in the Flipkart page, we had 40 items to be listed in that page, right? All the 40 items. See, Redmi 9 Nature Green 64 GB is 8299. Midnight Black is 8299. This is today's current rate for Flipkart. Every day it will change, and the analysis given to that consultancy project is every day if it is changing, it should be modeled with the corresponding price chart. See, for today it is increased, today it is decreased, and so on. They are actually showing, asking me to show a price chart, right? So these consultancies and all, depending on these kind of small programs only. That the viewers may think that it is a very big task, but we programmers know that it is a very small, scrappy kind of project, right? So those things I'll be dealing here, and in the first session of our lab, maybe tomorrow or in the next lab session, I'll be explaining you how to scrap this particular items. Not only name and price, whatever items initially, like Yogender said, price, rating, and everyone said, right? Those kind of processor, display, what kind of items you want, everything you scrap and then put it in the code. And just one time you scrap for a particular website, give them the class ID. All the items will be scrapped in a particular within 5 seconds or something, depending upon the capacity, right? And here I'm learning everything in Colab, right? Can you say what is the advantage of Colab compared to Jupyter?
Inbuilt GPU, sir.
Inbuilt GPU, very good. Next.
Next,
And packages are also already installed.
Yes, yes, actually, yes, I'm right. Both
inbuilt
Yugandhar and Achyutas
packages
are correct. And GPU
and
and packages. No need to
auto code
install
constructor.
package. Yes. When I do the things in Jupyter, it was actually somewhat difficult for me to import package and those kind of package errors. When I came to Colab, no package errors came to me. Whatever package I tried to use, it was actually pre-installed and nothing new for me, right? So that's the thing. And just as I could Colab and go to code, right? So you'll be having many examples also here, and you just see file new notebook. If you click file new notebook, you'll be getting a page. Another advantage of using Colab is it is a Google product. So if it is a Google product, all your programs will be saved it in your Google Drive itself. So that and all most useful, right? So if it in Jupyter, when I turn it into online Jupyter, sometimes it will be, sometimes it will not be there. Those kind of stuff will be happening. But in Colab, whatever things you type, everything will be saved in your Google Drive. So those kind of advantages are there while using Colab, right? My opinion is we can proceed our ML course completely in Colab. So those things are the steps we are going to deal with respect to the thing. So here, see, I got this is the Google Drive icon. It automatically say untitled one dot IPyNB. It is a notebook file, and it is saved in Drive also. See, so whatever I type here, everything will be coming in the Google Drive also. So I can retrieve anytime and any I can go on. While typing the lab exercise, so you can also type it as exercise 1, exercise 2, and so on, so that everything will be saved in the Google Drive itself. So that's what the main thing we are going to concentrate on, right? So Another website, what I'm interested in personally, it is used for me is PubMed. Hope somebody will know PubMed while doing your research-based evaluation. I'll be using this PubMed widely, PubMed and Google Scholar. PubMed is nothing but a paper extracting page where I can type like a pattern recognition. I want to extract papers regarding to pattern recognition. I just type pattern recognition. See, all kind of pattern recognition papers will be coming for me. Right? What are the things I can do? I can see paper name, sorry, paper title. Next,
Author's name.
yes, very good, very good. Author's name, and one other thing to see here is number of authors. In integer, if I numeric term, if I want to change, I can say number of authors. Next, see everything what is available here.
Year of publishing.
Yes, very good. One of the most important thing, year of published. Right. Next, see so many things are available here.
Publication ID.
Yes, PMID. Next, PMID is not publication ID. It is a paper reference ID. PubMed ID. PubMed ID. Next, see number of papers is available for some pages 365 to 372. This is the pages. What is the volume? Everything is actually available. And what is the journal? IEEE transaction biomedical engineering. So everything is actually available. So those things also I can scrap and I can do an analysis. Now, what kind of analysis I can do with this, right? So the one kind of analysis what I can do here is what are the common kind of papers available that I can choose. So I have typed here pattern recognition. I can also do some clustering over here. What kind of clustering I can do this? I can do a cluster based on some common authors, based on some a particular keyword, based on the journal, what kind of the things or number of papers. Anytime I can do some clustering and I can visualize my kind of papers. And if I use some NLP terms over here, I can extract the abstract. You see here, the abstract is also available. I can extract the abstract also, and I can use some NLP kind of things to analyze uh, as deep as possible and extract most similar papers also. Right, that and all is most useful for research purposes. So those things also I will do. So these things, this PubMed is personally I am doing is I have done this after doing this Flipkart Snapdeal. I have done this for my own purpose. I done the scrapping kind for these papers. Why? Because while writing papers, you need the paper title, everything, right? And you can have a site written over here, and you will be getting this site, right? I don't know how these things the website people is doing. I thought that I can do this citing by my own itself. So how to do this? That is very easy. Just to take the author ID. Next comes the paper title, and the next year and so on, right? But those who have done the RBE papers, everyone have done. So you know that for IEEE format, the citation is different. The reference format is different. So what I will do personally is I will take all my papers, all my references. I will take all the references and put it in an Excel file, and I can use some concatenation in Excel, and I can group them in such a way that first authors, then within double quotes, paper title, then a comma. What is the journal name? Then comma. Not year will not come here. Next I'll do a VOL volume dot what volume number, NO number dot 5 PP dot 633 hyphen 47 comma 2013. I don't want this DOI PMID and all in reference. So those things also we can do. Not for all the papers I'll do this. Just during some free times I'll try to do these kind of stuffs. So information retrieval is actually going to be most key component in any researches or any hackathons or any technical comps on challenges. So that's the thing we are going to learn in the next class, right? So I hope I have made the things clear and fascinating.